Hello everyone. Welcome to the technology webinar series of the Impact project. My name is Marcelo Orion. I'm the technical leader here at Impact and I will be hosting this webinar today for you. Before we start, let me introduce the scope and nature of what we're going to see in the next 40 minutes or so. This is a series of webinars that we have set up at Impact with the goal of explaining what the FIWARE technology is and how you can take advantage of it. The FIWARE technology, as you know, is one of the main benefits of our program, and it's also a requirement if you wish to participate in it. These webinars are aimed at introducing these technologies and helping you to better understand and use them in your projects. In the first webinar, we saw together an introduction to FIWARE technology to get in touch with it and to know how you can use it to help building your project. In the second webinar, we walked through the different FIWARE components and modules with the goal of helping you better understand the whole ecosystem possibilities and resources. If you remember, as we saw, resources are a very important part of the FIWARE ecosystem. Every partner involved in both the FIPPP and the FIWARE project has put a lot of effort in the development of the technologies and the accompanying tutorials, websites, and other helpful resources. So I really want to suggest you check out all the resources that you have at your disposal when designing your application's FIWARE architecture. Anyway, I was saying, in the third webinar, I gave you some interesting and first-hand insights about the use of enablers and the integration in your project's architecture. We saw how enablers differ from each other, not just in their area and functionality, but also in the coverage, the maturity, and the scope. By now, you shall have a wide view of the use of FIWARE and its integration in your architecture. So now, in this fourth Impact webinar, we're going to extend our vision of FIWARE enablers and the added value that their integration represents. We will concentrate on the interaction of the different enablers that fit together and allow your application to reach a high degree of features just by using the enablers. We will show you how you can use the Orion context broker along with a few other prominent enablers and how you can interconnect them to get valuable features that can help you get your application to the next level. You know that the FIWARE ecosystem is made of many enablers, and we're going to stress the fact that they really form an ecosystem and that the added value of the enablers integrated and connected together is really high and really valuable for your application, more than just the use of one isolated enabler. Of course, this webinar will be followed by others which will keep up to date the concepts that we're going to talk about just now. This is the structure of the information I wish to present you with today, following with what I just introduced. So first, a small introduction. Then we're going to take a look at the interaction of FIWARE enablers. We're going to go and see a FIWARE use case, a very interesting one, where you will be able to see many enablers implemented and interacting among each other with a business goal, with a clear business goal. This is a real project, by the way. It's live. Then we will finish with a deep look at the Orion context broker and specifically its interactions with other enablers to get you to see the power of this integration of the whole FIWARE ecosystem integration. At the end of the session today, we'll finish with a review of everything and also with some clear next steps for you to follow if you're interested in having your project backed by Impact, or if you already have your project backed by Impact and you want to really take the most out of FIWARE technology. Let's start then, if you're ready. Okay, let's go. Well, I want to stress the fact that this is the fourth webinar. We already made three before this one, and I really suggest you to go through them before watching this one, as they are a series of webinars that go that have a sequence, and it's really interesting to see them in order. In the first webinar, we just introduced the FIWARE technology and its architecture to help you understand the whole ecosystem and what FIWARE is about and what you can do with it. Then, in a second webinar, we walk through the different FIWARE components, modules, and general resources. And I want to stress this last fact because really there are so many resources out there online to help you get started and develop your FIWARE applications. Then, in the third webinar, we try to help you understand how to approach your application architecture, and we did this by taking a deep look at what we call the enablers inside. So, what enablers are meant for what, how they interact, and the little tips and tricks that you really need to take into account when you're developing an application using FIWARE. Well, now that you know what FIWARE is, what technology it includes, what its features are, and also you know a little bit about its insights, tips, and tricks, I plan to go one step further and show you how the different enablers interact with each other. As I said before, we refer to FIWARE enablers as an ecosystem, usually. And although I'm sure you can already see the way they fit together and complement each other, I think it's really interesting to see how that interaction works and to look at real life examples and the details beneath. So this is the way you will gonna get a real sense of how all the enablers interact with each other and how this ecosystem makes itself together. We will also look a bit deeper at the details of one of the most generic and widely used enablers, Orion Context Broker. And also, we will look at its interactions with other enablers and how it fits with other enablers. I'm sure you'll be able to see the power of the whole set acting together along this webinar. Let's see what these interactions are. In the last webinar, if you remember, we already saw a few business cases related to FIWARE. All of them, like Es Accesible, Small Signals, Smart Taxi, and Smart Fontaine, which is a project that we'll talk a little bit more about in a few minutes. All of them are live projects that are using FIWARE enablers. And in all of them, I mean, in all cases, the applications are using more than one enabler, and all the enablers that are used are linked together. Also, a common point in all these applications is that all are using Orion Context Broker as the basis of the interactions between enablers and the technology architecture. In many cases, context management and the context broker enabler is at the heart of the FIWARE architecture implementation in the application. So this is why I'm going to use the Orion Context Broker enabler to show you how enablers can be integrated and interact with each other. So for example, Orion interacts with all the other enablers in every category in different ways. For example, in the cloud category, Orion can be used to automate GE deployment. In the data category, you have, of course, the context management platform, and you can integrate the data and media content. In IoT is a very hot area to interact with Context Broker, and we'll see a big example of this a little bit later in this webinar. So, for example, you can plug and play the devices using IoT, and then program automated measurements and actions that are connected to the context broker, so that each time an event happens in one of these Internet of Things hardware, a signal is sent to context broker, and an event and an information is recorded. It also has a big connection with apps. And for example, in the web UI category, there is also a big interaction that can be done, as you can use the context broker to feed the web UI enabler with its information, so that you can get a visual representation of this information that is produced somewhere, and before it's consumed, it can be represented with a visual representation using the web UI enablers. This is a pretty familiar and common use of several enablers based on Orion Context Broker, which you can see here, and using also the CEP or Proton enabler and the Cosmos enabler. So, for example, in this context, which, as I said, is pretty common in some applications, you can find it in a few applications. You have the Orion Context Broker as the heart of the system. It's going to get all the information coming from the context sources, anything from IoT devices to people, other applications, etc. So the information is going to come and go to Orion. Some of the devices and applications are going to produce information, some others are going to consume it. And you have here the Proton complex event processing, and what it does is you can set rules for the Proton enabler to send alarms and to send messages whenever some conditions on the context information generated by Orion are met. And so you program some rules, like for example, you could have an IoT device here, like a sensor, sending information to Orion about its temperature, and then you could program some rule in Proton saying that whenever this temperature goes above a certain level and some other conditions are met, a signal is sent, or even a signal is sent to the application, or even an information is sent to Cosmos, Big Data Enabler, or an information is sent to Orion back so that it can be consumed by the application here. So this is the way Orion and Proton interact. With Proton, you set up rules on the basis of the information that is gathered at Orion. Then you have Cosmos here, and you can use Cosmos to process all the data coming from Proton, because sometimes this data can be a lot of information. It can be many alarms can be set up, and many messages can be sent from Proton to Cosmos. So according to the processing and analysis algorithms that you set up on your applications, you can use Cosmos to evaluate this data and to process it and to create information that goes to Orion and that can be consumed by the application. So there are many possibilities using all the ecosystem of these three specific enablers. You can see here a more detailed representation of this scheme that we were just looking at. And you have the FIWARE ecosystem here, the FIWARE architecture here, with all the with the three enablers that we just saw, plus the sensor to things enabler, which is charged with the connection with the IoT's devices. So here you would have the devices that communicate with the FIWARE ecosystem that we just saw. Before we finish this chapter about interaction, enablers interaction, I want to show you this diagram um, which shows a big integration between many FIWARE enablers. It's what we call the target smart city platform, and it's a proof of what can be accomplished with all the FIWARE ecosystem. Of course, it's not common that you will be using all of these enablers in your project, of course. But this diagram just wants to show you how the different enablers can be connected to one another and how they can interact with the outside world here and with the applications and the devices here, and it's a whole ecosystem that is it's interesting for you to take a look at, and also to use it as a reference when you're developing your application architecture, as you can see here how each enabler can connect to the others and how information can flow from one to the other. So I think it's a useful diagram. Now I'm going to present you a use case, a very interesting use case of a project that is running with FIWARE technology. It's a live project. It's part of the Smart Cities initiative, and it's called Smart Fountain. This is a project that is from a company in Seville, Spain, and it's about the management of fountains, of public fountains in the cities. So, if you think about it, fountains are something that are really offline. Let's say they are managed in a very offline way, not automated at all, and there are many problems around fountains, around public fountains. For example, there are water leakages, and there are maintenance problems due to acidity, chlorine, temperature deviation. There are problems regarding the flow of water when there is too much wind or where there's rain. So, for example, if there's too much wind, the water needs to get down, the water flow, so that it doesn't the water is not lost due to the wind. Or, for example, when it rains, the fountain has to be stopped, or some water at least needs to be recovered. Or, for example, when the temperature goes below a certain level, the fountain has to be stopped because if the water freezes, the fountain can get damaged. So, as you see, there are many things, many problems around something as simple as a fountain. And of course, there are already solutions that take this into account and that try to address these problems. And there are some pieces of hardware, some sensors that already exist and that can be connected to the fountains. But the problem is that there are many vendors for this hardware, and each of them has a different and proprietary software solution, which makes the operation a bit complicated. And also, there is no remote operation for all this. So, a smart fountain is a project that was built to address all these problems. What are the tools used by a smart fountain project? Well, of course, the FIWARE technology. This is why it's a use case. Then they use different set of meters. For example, they have sensors and meters for acidity, for chlorine, for temperature, for some electric parameters, for pump. These are all Internet of Things connected hardware that the company uses to measure the events on the fountains and to be able to act upon them using the software. And then finally, they also use their own design specific devices. They're called A Device. This is also the name of the company. Very interesting company, by the way. And these devices are used to connect all these matters to the Internet of Things. So they kind of, you can look at them, you can look at these devices as the enablers for the matters to be connected to the system. So they transform regular matters into Internet of Things ready devices. And how does it all work and how is connected to the software side and to the FIWARE enablers specifically? Well, the first step is to connect the matters into a gateway and make a data model. Make a data model using Orion Context Broker. So Orion already appears as the heart of the system. So they connect all the matters using their specific devices, their own made devices, and they connect them into this gateway and make a data model in the context broker. They publish this model, of course, and they send periodic measurements via M2M. So basically, the devices, the matters, send their signals to the IoT devices, which in turn send their information to the model and publish the information that is then available for the applications to consume. They test everything with YCloud because before being able to make everything into production, YCloud is a very nice way and very convenient way of testing everything, testing all the systems. So you can personalize all the enablers and the model, and then test them with YCloud before going live. All the information that goes to the context broker, as we saw before in this diagram with all the enablers, is then processed with CEP, Proton, the Proton enabler, which is able to be configured with alarms that set up and then go off, depending on the data measured by the context broker. And so the application can subscribe to these alarms. So we already have the sensors that send their information to the context broker, and some alarms that go off and inform an application whenever a set of this information sent by the sensors and united in the context broker reach certain levels and meet certain conditions. And then, of course, you can already interact and do things with this data. Like, for example, when you get an alarm because the temperature has gone below a certain temperature and the wind is blowing above certain temperature, you have to do something, a maintenance thing, and an alarm go off to the application, and so the technician can go and fix whatever he has to fix. And then there is another part of the system which logs all these measurements using the big data generic enabler to be analyzed lately with the goal of building predictive algorithms, so that next time you notice that some measurements done by the sensors are met, and you have deduced using the big data analysis that these parameters usually cause a problem in the front end, you're able to go to predict it and to act before the problem is there. This is the scheme showing the FIWARE architecture I just explained, and you can see that the application makes use of 5 generic enablers. Of course, Orion is at the heart of everything, and here you can see it here, context broker. Then you have the CEP, Proton, complex event processing, to transform the information gathered by the context broker into alarms, into usable and actionable alarms. Then you have the wire cloud in the server to test everything. And of course, the IoT adapters and the IoT backend device management enabler, which is connected to all the sensors and all the IoT devices that gather the information and send them to the system. And so you can see a pretty interesting architecture here, making use of these 5 generic enablers. These are really stable enablers, and this is a pretty common way of using them all together. And I hope you have seen how they interact among them. Here you can see a screenshot of a communication done with the context broker. This is just REST API client used to interact with the context broker installation, just as an example of the data and their operations that can be done in this specific architecture. Here you can see the use of the wire cloud enabler in the application. You have all the widgets here, and this is how they're connected. So for example, you have a widget which is called Fountain Query, Fountain Widget, Map Viewer. We're gonna go into some of this detail in a bit regarding the Map Viewer or for the geolocation part of the project. And here you can see how the widgets are connected to each other. It's I mean, for all of you who are programmers, this is gonna look pretty familiar because it's like it's very similar to a database scheme. Here's a look at the Fountain widget in WireCloud, and it gives you a very good feeling of how you can use WireCloud in your application. This is the widget, and you can see all the data coming from the sensors. And so it's kind of an interface which you can use to interact with the application in a graphic way. Here you can see the installation of the Proton enabler, CEP. And well, in general, that would be the solution. I think it's an interesting use case. FIWARE is in the center of it all. It's a project that is live, that is working, that is being very successful, and I think it's a very nice use case that you can use as a reference for your own application development. Let's take a look at another case of FIWARE enablers integration. This is going to be a more generic and general case, and it involves the integration of several enablers around Orion Context Broker. So it's a continuation of what we just saw regarding the Fountain project. Let's begin with a small reminder of what a context broker is. So, in general, a context broker, and Orion in particular, is just a piece of software that you put somewhere in your architecture, somewhere mostly at the heart of the architecture, and which is able to mediate between information producer applications, that is, applications that produce information, like for example sensors, or an application used by a person, by someone that gives some kind of information to the system. And on the other side, the context consumer applications. So, for example, apps that access the context information provided by the sensors. So it's basically kind of a middleware, very generic, and you could say it's a layer on top of a traditional database access system. Why would you need to have a specific software component to manage information when you can just use the database? Well, because to use a context broker like Orion has many advantages over the use of direct connection to database and your own classes or developments to access it. When you use a context broker, the information is represented using values assigned to attributes. So all the information you have is organized in attributes of objects that have values. And by using a context broker, you're able to handle information at large scale. Your application can query the context information that other applications or the same application has written before. You can subscribe to changes in information, and these subscriptions will be received in the form of notifications to your application, and then you can act accordingly. And also, you can enable your application or any other application, in fact, to modify the context information. So, as I said, you have producers and consumers of this information that is stored centrally and to which you can add a notification system. So in your application, you will have objects that have attributes, and each of these attributes will have a value at a certain time. So if you're familiar with the concept of object-oriented programming, and I'm sure you are, this scheme reflects exactly the OOP paradigm. So, for example, your application, let's say that your application will have several entities, three entities: a bus, a person, a shop. Each of these entities will have several attributes. For example, the bus has a location, number of passengers, a driver, the license plate, and all these attributes can change in time. So they can be different in different moments of time. So there's an application that's going to write these the values of these attributes at any time, and other applications can read them accordingly. And you can also set up notifications. Same goes for a person object, for a shop, and so on and so forth. Context information encoded in the context broker may come from many different sources, machines as well as humans using applications and using different interfaces and protocols. But the magic of this enabler is that when you program your application, you just need to care about entities, their attributes, meaning the values of the attributes at a given moment. Your application, when used as a consumer, as an information consumer, can just access a specific attribute at a specific time, at a specific moment, or set up a notification and get notified whenever an update on a context information takes place. Like, for example, you could code on your application an alarm notification saying, like, notify me when bus X, a specific bus, arrives at a specific bus stop. And well, of course, you do that through the API. And then whenever the bus through the IoT device attached to it writes to the context broker that he has arrived, it has arrived to the stop A, then this notification just goes to your application and you can do whatever logic is applied to it. And from a producer perspective, acting on a device is easy as changing the value of the attributes linked to its entity. So the only thing the lamp in this example needs to do to make sure the applications are notified of its change of status So whenever it goes on and or off, is just to write its new status using the context broker. So that would be the producer side. Simple, as you can see. You can see here a scheme representing the Orion architecture, and as you can see, it's made up of two sides. So on the one side you have the context producers, which are updating the data constantly, and on the other side you have the context consumers, so the information consumers, which can load the data and through queries or through notifications. This shows a scheme where you can see the Orion enabler architecture. And so on the one side, you have the context producers, which are updating the data on the context broker constantly. And on the other side, you have the context consumers, which are consuming the data on the context broker, and they can do so either by fetching queries to the system or by getting notifications from it. So context broker operations consist of on the creation and pulling of data. So context producers publish data elements by invoking the update context operation on the context broker, whereas context consumers are retrieving data elements by invoking the query context operation on the same context broker. And so in a way, the context broker is in the middle of it all, connecting consumers with producers. As to the push data, context consumers can subscribe to receive context information satisfying specific conditions using the subscribe context method. And you can also specify a duration for this subscription, for these notifications or alarms if you wish. The context broker notifies updates on the context information to the subscribed context consumers using the notify context operation. An interesting feature of the context broker enabler is geolocation. So what this allows is for entities to have an attribute that specifies its location using a specific metadata. And so, for example, you can create an entity called Madrid, which would be of type city, and this would have an attribute called position defined as location. So this is the specific of it, the location attribute. And so, for example, you would state that coordinates for Madrid are a certain latitude and a certain longitude. And of course, Madrid is not going to move, or any city in that sense. So it wouldn't make that much sense to have a city with these attributes. But of course, think about a bus that is moving, or a train, or any IoT device which is subject to movement and to geolocation data. You could have this data encoded in the context broker, and therefore available for every application. And what we've seen so far is just the beginning of the magic. What really is interesting is what happens now when, for example, you connect the context broker with IoT devices. Because when you do that, to capture data from or act upon IoT devices, an application just needs to read or change the value of attributes linked to the context entities using the context broker. So in that way, the operation of a lamp to act upon it, like turning it on or off, can be done through these operations, through the information that goes from the lamp to the context broker, and from there to the applications connected to it. And of course, not just read or write information from IoT devices, but also applications can get notified, so they can subscribe to notifications and they can get notified whenever a specific update on context information that is being monitored takes place. Like, for example, you would say the IoT device connected to the bus would write to the context broker the fact that this bus has arrived at the stop A. That would be written to the context broker, and from there, the context broker would notify a specific application that has subscribed to this specific alarm whenever it takes place. And think about the magic that can happen because this information can come from many sources, not just IoT devices. So, for example, it can come from external systems that use APIs to export data to the context broker. It can come from users that are using mobile apps. There are millions of combinations. Applications just need to use OMA and GSI as a single standard, simple and powerful API to connect with all the information producers and get the information they need to implement the feature they're looking at. The integration with sensors is a given, therefore, as the backend IoT device management generic enabler enables the creation and configuration of IoT agents that connect to sensor networks. So this is another example of the way you can combine all the enablers to get your specific features up and running. And of course, in this case, each CNGSI IoT agent will behave as a context consumer or context provider or both, even both, just as you need. And last, to end with this big review of the context broker enabler, bear in mind that every FIWARE enabler can be used in connection with the context broker, because once context information is gathered, any FIWARE enabler that is thought to be consuming information can be connected to it and take advantage of it and build these features in a broad sense. So you can connect it for big data analysis, as we saw in the example of the fountains just sooner. You can connect it to complex event processing, can connect it to advanced web-based UI, open data publication, and so on. So I hope the power of the enablers interaction is clear for you now. So we're getting to the end of this webinar, but I don't want to finish it without reviewing with you the next steps you should be taking in order to advance in your impact implementation with FIWARE technology. Let's sum things up. Then your next steps towards the use of FIWARE technology should be first, using the catalog to identify and select the general enablers that fit your project's needs. Then use FIWARE and the rest of the resources available online to learn more about the enablers you already selected and how they work, etc. Then you should set up an account at FIWARE Lab to begin testing your GEs and your own developments in a live environment. Finally, you should modify your architecture to make room for FIWARE. Always, of course, remember the facts we saw, the special facts we saw. FIWARE enablers make up an ecosystem. This is what we've seen today, and interaction is really key to make projects work and to make projects get value from FIWARE. Also, remember that Orion Context Broker is one of the most generic and widely used enablers, and you should keep it in mind whenever you're choosing or deciding on which enablers to use in your architecture. And of course, its interactions with other enablers are very powerful and make the whole thing much more valuable for you. Of course, as you know, Impact is here to help you. and you have several channels to get help. If your project is selected, we will help you integrate FIWARE in your architecture, and we will always balance technology and your business and FIWARE and your business. We will always try to help you in the implementation. So rest assured about that. So where do you go from there? So next steps I suggest for you is to check all the information, select the enablers that can be useful for you, use the FIWARE school and the other resources to learn more about them, set up an account at FIWARE Lab, test and develop and begin again. And that's it. Stay tuned for our next webinars because we're going to be looking at other aspects of FIWARE technology in order to help you implement it in your project. I hope this was helpful for you. I hope the integration of the enablers and the possibilities that it offers are really clear for you now. And I hope you enjoyed this webinar. Thank you very much and goodbye.